Prompt engineering is vital since it helps communicate effectively with the large language models or LLMs. Prompt engineering means framing the proper user prompts so that LLM can generate the desired output. Constructing a correct prompt is crucial to avoid hallucination, where LLM responds with the incorrect result. Hence, in this video, we will look at the 5 crucial prompt engineering techniques that can be helpful when querying large language models to obtain relevant results. Let's start with the zero-shot technique. Large language models, or LLMs, such as Claude 3, GPT-4, and GPT 3.5 Turbo, are trained on massive amounts of data. This extensive training is the key to their ability to perform tasks in a zero-shot manner, showcasing their remarkable learning capacity and potential applications. Zero-shot prompting means that the prompt used to interact with the model won't contain examples or demonstrations. The zero-shot prompt directly and simply instructs the model to perform a task without any additional examples to steer it, demonstrating the power and simplicity of these models. An example of a zero-shot would be asking about the sentiment of the statement like, "I think the weather is okay," to which LLM will respond with a neutral sentiment for the statement. Similarly, we can ask LLM to solve the following math question, to which it will respond with 16 as the answer. We should note here that we did not provide the LLM model with any examples for context. Hence, they are the examples of zero-shot prompts. Let us talk about the few-shot technique now. This technique is beneficial when the large language model needs to perform a task it hasn't been explicitly trained on, or when it needs to adapt to a new context. Few-shot prompting, in particular, can be used to enable in-context learning, where we provide demonstrations of the prompt to steer the model to better performance. The demonstrations serve as conditioning for subsequent examples where we would like the model to generate a response. Following is an example of a few-shot technique. Here we have provided the LLM model with the sentiment for 2 of the statements made, with the first one having positive sentiment and the second one having negative sentiment, and then asked LLM to find the sentiment for the third statement. LLM provides the negative as a sentiment for that statement. Here we can observe that the model has learned how to analyze sentiment with 2 demonstrations. There are a few variations of few-shot techniques based on the number of demonstrations we provide to the model. For example, with just 1 demonstration, the technique is known as a one-shot. Other variations like 3 shots, 5 shots, etc., are used for more complex tasks. The next one is the chain of thought or COT prompting technique. This technique was introduced by Wei et al. In 2022. In the case of the chain of thought, instead of providing the direct answer to the example prompt, we provide the LLM with the steps that help to reach that answer, along with the answer itself. Hence, we ask the LLM model to think in a step-by-step manner, which can lead to more structured and accurate responses. The COT prompting technique is specifically helpful for complex problems where a detailed explanation is required. The following example taken from Wei et al. Shows the chain of thought prompting technique. As shown in the example, on the left side in standard prompting as part of modal input, when providing the direct answer to the first question, the LLM model predicts the incorrect output for the next question that we ask for. However, on the right side, we demonstrate to the LLM model how we reach the answer of 11 by providing intermediate reasoning steps. This forces LLM to think step by step, and as a result, it gives the correct answer to the following question that we ask. Next, let us look into prompt chaining. The prompt chaining technique enhances the reliability and performance of LLMs by breaking tasks into subtasks. Once those subtasks have been identified, the LLM is prompted with a subtask, and then its response is used to input another prompt. Thus, in the prompt chaining technique, a task is split into subtasks with the idea of creating a chain of prompt operations. Prompt chaining is helpful for accomplishing complex tasks that an LLM might struggle to address if prompted with a very detailed prompt. Consider the following example demonstrating prompt chaining. Let us assume we want LLM to help us plan on buying a gaming laptop based on specifications like RAM size, graphics card, CPU type, and laptop price. Then we break this task into smaller subtasks by first asking the LLM about the list of 5 popular laptop brands for gaming. Then, on the response that we receive from LLM, we ask it to add the specifications like their price, RAM, storage size, CPU type, and graphics card type. Then, on top of that response, we can ask LLM to sort them based on price or other relevant criteria. The above example shows how we broke down the task or prompt into smaller subprompts, with each next prompt building on top of the previous response that we received from LLM. Hence, it is an example of prompt chaining. Next, we will look into the self-consistency prompting technique. Self-consistency is one of the most advanced techniques in prompt engineering proposed by Wang et al., where we provide LLM with multiple diverse reasoning paths through multiple few-shot chain of thought examples and use the generations to select the most consistent answer. Majority voting is done for the multiple prompt responses that we receive from the LLM for the final input prompt, where the most frequently occurring answer is chosen. This helps to improve the performance of chain of thought prompting on tasks involving arithmetic and common sense reasoning. For example, when we provide the following arithmetic reasoning prompt, LLM model might give 35 as output, which is incorrect. To correct this, we can feed LLM with a few-shot chain of thought examples, such as the following, and we provide the same input prompts to LLM in the end, for which LLM generates multiple outputs. We select the output with the clear majority, which is 67 in this case. To summarize, we saw 5 primary prompt engineering techniques, namely zero-shot, few-shot, a chain of thought, prompt chaining, and self-consistency. You can explore combining these techniques further to produce even better prompts for LLMs. I hope you find this video helpful. Subscribe to learn about other prompt engineering techniques.